Okay, students, so welcome to the lecture on the use of the HP12C financial calculator. And hold on, Teresa, can you let me know if you see the calculator on your screen there?
Yes, I can see it.
Okay, good. I think we're good then. Okay, so I'm going to go through the steps on using the financial calculator. First thing after you turn it on, of course, is to set the number of places after the decimal point. If yours displays 0.00, that's going to end up to be not enough digits after the decimal point. So I'd like to generally make it at least 4 places. The way to change the number of digits after the decimal point is to hit the orange F button. And hopefully you can see my mouse as I do these steps. So hit the orange F button and then hit the number of decimal places that you want, or the number of digits after the decimal place. I'll just make it 5, so I'll hit 5. As you can see, the display now shows 0.00000. So I would recommend, again, F4 or F5, so setting it to 4 or 5. Okay. Next thing to remember, and some people say you don't have to do this, but I like to do it anyway. Every time you're going to do something new on the calculator, I like to clear not only the regular memory, but the financial memory. That's the memory that takes care of the time value of money stuff. I like to clear all of those. Okay, so there's 3 things you have to clear. And let me just kind of put something there now. Okay, so first thing you do is clear the display. And you do that by hitting this CLX button. So it'll go back to the 000, okay? Next thing you need to do is to clear the regular memory. So if you have anything in memory, and I'm not gonna go over that, but you can store stuff into memory by using this STO button. But again, I won't go through that right now. But clearing the regular memory is you hit the F, and then see right above CLX has the orange REG. That means that if you hit the F button, it'll revert to the orange. So the regular memory, hit the CLX button. You've now cleared the regular memory. And then the third thing you have to clear is the financial memory. So see this FIN in orange here. Click F, and then this XY button here. And that clears the financial memory. As I said, I like to do that before every single calculation that I make, even though it may sound like you don't need to do all 3. I do it anyway because it's not really hard to do. Okay, so every time you use a calculator, make sure you clear it. Let's see, another thing to remember, if you ever want to change the sign of something, so for example, 55, if you want to make that a negative, see this CHS button, change sign. Okay, so hit that and it'll become a negative. Okay, let me clear that. Okay, next thing I want to show you is adding, subtracting, dividing, multiplying. The HP12C uses reverse Polish notation, which means it's kind of backwards from what you're used to. So for example, if I wanted to add 5 plus 6, the way to do it on this calculator is first you have to hit the first number that you're trying to do the equation with. So 5, and you have to enter the first number. So hit the enter. Then you hit the next number that you want to do something with. So that was 6, and we wanted to add it. So hit the plus. There you can see the answer is 11. So it's kind of backwards. You can't do 5 plus 6 equals. You have to do 5 enter 6 plus in order to do it. So if you could, and let me clear it again. Okay, so if you could just practice adding, let's say 7 plus 9. So do that on the financial calculator. You know what you're supposed to get. So see if you can get that number. So 7 plus 9. Okay, so the way to do 7 plus 9 again is you hit the first number 7. And again, if it's the first number in the equation, then you have to hit the enter button. Then the next number, 9, and then plus. And there you get your 16. Okay, so again, it's called reverse Polish notation, which is the kind of backwards from what you're used to. Okay, so similar thing with subtraction. Let's just take 14 minus 6. So 14 enter, 6 minus. Okay, then multiplication, same thing. Let's take 20 times 10. So 20 is the first number we're going to use. So we enter it, and then the 10 multiply it. So you get to 200. Okay, and then let's say division, let's say 500 divided by 10. So 500, enter, 10 divided by to get to 50. Okay, so that's how you add, subtract, multiply, divide. Again, it's the reverse Polish notation. For those of you who have the HP12C Platinum Edition, you can actually change that setting to make it look like a regular calculator when you're adding and subtracting. Okay, but for the regular HP12C calculators, it's stuck on that reverse Polish notation and you cannot change that. Okay, okay, so that's adding, subtracting, dividing, multiplying. Okay, so now let's take a look at the present value concepts. And you read in the chapter, present value, the concept is $1 today is worth more than $1 in the future because you could invest that dollar today and it's going to grow to more. And the further in the future it is, the less it's worth compared to the present value. Okay, so the 5 different buttons that you're going to need to do present value or financial time value money calculations are all across the top here of the calculator. So the top left row, the N, I, PV, PMT, and FV. So N is the number of periods that you're looking at. So if it's 5 years in the future, it's N is 5. If it's 30 months in the future, N is 30. So it's not necessarily years, it's the number of periods that we're going to be looking at. Okay. I is the interest rate. Interest rates are always expressed in annual terms. So if it's 12% interest, then this is the button to use. I'll get into it a little bit later, but if it's other than annual interest, if it's monthly interest, for example, then we would put in the monthly interest percentage in this I button. Okay. PV is the present value. That's the amount that, that's a dollar amount of something today. Okay, so if I gave you $100 today, that's the present value because you're getting the money today. Let's jump over to FV, future value. That's the value of money in the future. Okay, so 5 years from now, if I were to give you $1,000, that's the future value, $5,000 or whatever I said I'd give you. Okay, so this is, FV is the amount in the future, so a single lump sum amount in the future. PV is the single lump sum amount today. This PMT button is a special button that's used for annuities. And an annuity is a periodic payment, so the same amount every period for X number of periods. Those periods can be months, can be years. Okay, so if for example $1,000 a month for 20 months, the PMT button will be that 1,000. So that's a single amount in a series of same amounts. And to use the PMT button, the series of payments have to be the same amount. If it changes, the amount changes, then you can't use that PMT button. Okay. Okay, so those are the 5 buttons that we're going to be using in this course. There's some other buttons. I mean, there's a whole lot of other buttons that are used for bond pricing, net present value, internal rate of return, etc., that we aren't going to cover in this course, but we do cover in an accounting course. Okay, so anyway, let's look and see how we use these 5 buttons. So, of those 5 variables, in order to find one of them, you need to input 3 other variables. Okay, so again, you need to input 3 variables in order to solve for a 4th one. Okay, so let's take this example, a fairly simple example. Let's say I were to give you $100 today, and I tell you that you can invest it, the interest rate is 12% a year. Okay, that's sometimes called the discount rate. Okay, so I give you I forgot what I said, but let's just say $1,000 today. It's going to grow at a rate of 12% a year. How much will I have at the end of 5 years? Okay, so let's see what are the variables that we do know and which one are we trying to find. So I'm giving you $1,000 today. So I'm giving you an amount of money today. So that's present value. Okay, so follow along with me as you go through this. So 1,000 is the present value because I'm giving it to you today. You're going to grow it for 5 years. So 5n, number of periods is 5. And the interest rate was 12% a year, so 12i. Okay, so we've got our 3 variables. We're trying to calculate how much money will you have in the future. So that's the future value. So now all you do is hit that FV button and ignore the signs. Okay, it's going to be the opposite sign of the present value that you input. So ignore the sign for now. I'll tell you in a little while when we do take the signs into consideration, but for now, ignore it. Okay, so you'll have $1,762.34. Okay, so again, if I gave you $1,000 today, if you were to invest it at 12% a year for 5 years, in the future, you'll have 1,762.34. Okay, so that was calculating a future value. Why don't we go ahead and do a practice problem. So let's say that I'm going to give you $5,000 today, and you're going to invest that for 10 years. And the interest rate you'll be getting is 8% per year. Okay, so again, $5,000 I'm giving to you today. You'll be investing it for 10 years. The interest rate is 8%. How much will you have at the end of those 10 years? Okay, so go ahead and try to do that calculation, and in a second we'll go over it together. Okay, so let's go through that calculation. So the variables that we do know, I said I'm giving you $5,000 today. So if it's today, that's the present. So that's the present value, $5,000. I told you that you would be investing it for 10 years. So 10N. And the interest rate was 8%. So 8I. Notice you don't have to worry about moving the decimal places. So it's not 0.08 for 8%. It's simply 8. So 8, and I hit the I, yeah? And then the question is, how much will you have in the future? So how much will you have 10 years from now? That's the future value. So all you do is hit the FV button, and you would have, if I did this right, $10,794.62. Okay, so let me just make sure again, and don't forget, every time you do a new calculation, clear all three memories. So let me do that again just to make sure. $5,000 is the present value. That's how much you're given now. 10 years, so 10N is the number of periods. 8% per year, 8I, and then hit FV to see what the present value is. Yeah, so you'll have in the future, future value is, so you have in the future $10,794.62. Okay, that's the calculation of the future value. Okay, so let's do something different. Okay, let's say, excuse me, that you need to have $10,000 5 years from now in order to buy, let's say, a car. Okay, so you're going to be putting away a sum of money today that will grow to exactly $10,000 5 years from now. And let's say the investment rate or the interest rate is 10%. Okay, so again, you have to figure out what three variables do we know. Okay, and again, the question is, how much do we have to put away right now, one-time lump sum, in order for it to grow? Okay, we know we need $10,000 in the future. So that's the 10,000 is the future value. We know that we need the money 5 years from now. So 5N. And the interest rate was 10% a year, so 10I. And what we're looking for is trying to solve for what amount of money today. So that's the present value. So just hit the PV. So $6,209.21 is the present value. That's how much money we need to put away now. Invested at 10% a year for 5 years for us to have exactly $10,000 then. Okay, so that's a calculation of a present value. Let me give you a little exercise here. So let's say that the future value is $100,000. And we're going to be investing for 20 years at an interest rate of 15% per year. And because, in doing these problems, you assume a constant interest rate throughout the entire period. So whether it's an average or just assume that it's not going to change, you have to make that assumption in order to do these calculations. Okay, so again, future value of 100,000, 20 years of investment at 15% a year. What's the lump sum amount of money we need to put away today in order for it to grow to that $100,000? Okay, so do that problem, work on that a little while, and in a couple of minutes we'll go through the solution to that. Okay, so again, we need three known variables in order to calculate a fourth unknown. So what we do know is we want to have $100,000, so 100,000 in the future. So that's future value. Okay, we know we're going to be investing for 20 years. So 20 is a number of periods. That's N. And the interest rate was 15% a year, 15I. And then We want to know how much we're going to put in right now today. So that's the present value. That's what we're trying to solve. So just hit the PV button and you'll see that $6,110.03 approximately is the present value. Okay. So that's the calculation of the present value. So again, all you have to do is to input 3 known variables out of those 5 there, and we'll get to the PMT in a second here, in order to calculate a 4th unknown variable. Okay, so you can do the same thing in trying to solve for a number of periods, n. You have to input the I, the PV, and the FV. Well, let's do one of those because there's a little catch to that one. Okay, so let's say that we have a amount of money today of $10,000, and let's say that that's going to grow to be $22,000 10 years from now. Okay, so we have $10,000 today. That's going to grow to $22,000 10 years from now. What interest rate do I need to achieve on the average for those 10 years in order to get that $22,000 in the future? So the 3 variables that we know are, we know that the $10,000 is the amount of money we have today. So if it's today, that's the present value. We also know that $22,000 is the amount we want in the future. So that's future value. Okay, here's the little trick. Anytime you're inputting 2 dollar amounts, so when you're inputting both a present value and a future value, or as we'll see in a second, a present value and a payment, or a future value and a payment. So whenever you're inputting 2 dollar amounts, you have to make one of them a negative, and it doesn't really matter which one you make a negative. In this case, let's make the future value of 22 negative. So remember, input 22000, 22,000, then hit the change sign button to get it to be negative, and that's the future value. That's how much we want to have in the future. So remember, I input $10,000 as a positive amount into the present value button. So when I'm inputting the future value of 22,000, I have to make that one a negative. You could have done it in reverse. You could have made the 10,000 a negative, put that into present value, and make the 22,000 a positive future value. Okay, as long as the signs are opposite of each other for the present and the future values. Okay, so we've input present value, we've input future value, and now we know that 10 years was the number of periods, so 10n. And what we're trying to find out is what's the interest rate that we need to achieve. So that would be you're solving for I. So just hit the I button. So we need an interest rate of 8.20%. Okay. So that's solving for I. So we could do the same thing for n. But again, just remember, whenever you're inputting 2 different dollar amounts, you make one negative. Okay, so let me clear this. And again, it's not necessary, but I clear all 3 memories anyway. Okay, so here's the problem, practice problem. Let's say you have $50,000 today. You want that to grow to be, let's say, $85,000 7 years in the future. Okay, so again, $50,000 now. You want it to grow to be $85,000 7 years from now. What interest rate would you have to get in order to have that 50,000 grow to be 85,000? Okay, so go ahead and work on that problem, and in a minute or so we'll go over it. Okay, so the three variables that we do know is the $50,000 right now. And just for a different approach, let's make that one the negative. Okay, so 50,000, you see the minus sign in front. That's the present value. We know we want to have $85,000. Whoops, clear that. $85,000 in the future. Since we made the present value a negative, we'll keep this one a positive. We know that we were going to invest for 7 years, so 7N. And we want to know what interest rate we would need to achieve that goal. So just hit the I. 7.875% is what we'll need then. Okay, we'll need to get an average of 7.875%. Okay. Okay, so that's the basics of the four of the buttons here that we've used: the N, the I, PV, and the FV. Before we go on to see how we use the PMT, let me go over a problem not on an annual payment type thing. Okay, so in the problems we've done, we've assumed annual compounding. What annual compounding means is the interest is calculated on the principal plus interest once a year. So we're calculating interest once a year and adding that to the principal amount. Okay, that's compounding, means you're increasing the percentage of interest because you're calculating interest on interest. Okay, that's compounding. Annual compounding means you're recalculating that interest once a year. But it doesn't always have to be an annual compounding. So let's assume that we have something that's compounded monthly. Okay, so every month they recalculate the interest and then add any interest to the existing balance, so the interest amount keeps growing. Okay, so let's assume a monthly. So let's assume that we have $1,000 today, okay, and we're investing for 5 years, and the interest rate is 12% per year. But let's assume that it's monthly compounding. So if it's monthly compounding, what we have to do then is figure out the periods is not 5 years then, because it's compounded monthly, it's 5 times 12, or 60 periods, or 60 months. So the N in this case will be 60. The interest rate, 12% per year, but we're looking at monthly, so we divide that by 12 to get 1% per month. Okay, so the general rule is whenever you have compounding other than annually, you multiply the period, the number of years, times the number of compounding periods in a year, and you divide the interest rate by the number of compounding periods in a year. Okay, so in this case, we multiply the N, 5 times 12 times a year, because it's monthly, that's 60. And the 12% per year, because it's monthly compounding, we divide by 12, so 1% per month. So what we do then is input the present value of 1,000 as PV. The number of periods is now not 5 because it's monthly now, so 5 times 12 or 60 is the periods. And the I was 12 divided by 12, or 1 is the interest rate because we're looking at it per month now. And then we want to know what the future value is, so we just hit the future value, $1,816.70 is how much we'll have in the future. Okay. Okay, so let's do a practice one there. Let's say the present value is $50,000, 50. we're going to be investing for 7 years at a rate of, yeah, let's just say 12% per year. And again, let's assume monthly compounding now. So how much will they have in the future, this in 7 years? So 50,000 today, invested for 7 years at 12% per year, but it's monthly compounding. Okay, so work on that one, and we'll go over that in about a minute or so. Okay, let's take a look at this one then. Okay, so we know the three variables are the $50,000 that we have today. So since it's today, it's present value. We're going to invest for 7 years, but because it's monthly compounding, it's 7 times 12. And you can do the math right here on the calculator. So 7, enter, 12 times 84. And that's what we want for N. Okay, the number of period interest rate, is 12% a year, but it's monthly, so 12% a year, 12 enter, 12 divide, so 1% a month. That's the I. And we're trying to find the amount in the future, so that's the future value. Just simply hit that button. So that will grow to 115,336 and 14 approximately cents. Okay, so that was other than annual compounding. We could have had an example of daily compounding. If that's the case, then you simply multiply the number of years times 365 to get the daily number of periods, and then take the interest rate and then divide by 365 if it's daily compounding to get a daily interest rate. Okay, so the compounding periods could be annual, could be quarterly, could be monthly, could be daily, depending on the situation. Okay, so that's basically the use of the 4 buttons, the N, the I, PV, and FV. Now let's take a look at using the PMT button. And again, remember, PMT, that button is used only if it's a series of similar same payments. So it's the same amount for X number of periods. That's when you use the PMT button. So for example, if I were to say, you have $100, you're going to be putting away $100 a month. And again, notice it's month. Okay, $100 a month for, let's say, 10 years, which is 120 months. And the interest rate is 12% per year. Don't forget, interest rates are always quoted in annual terms. Okay, but we have to adjust that since we're doing monthly compounding. We have to divide that by 12. So we get 1% per month. Okay. So how much will we have at the end of that 120 months? So again, you're putting away $100 per month for 120 months, and the interest rate is 1% per month. Okay. So the variables that we know, let's look at the easy ones. We know we have 120 months. We know the interest rate was 1% per month. And we know we have a $100 payment per month. Okay, $100 is a series of payments. It's an annuity. So that 100 is the PMT button. And then you hit the FV to figure out how much you will have at the end of those 120 bucks. So $23,003.87. Okay. Again, the PMT button is used for an annuity. That is a series of same payments over X number of periods. Okay, in this case, we're making the assumption that the first payment was made at the end of the month, the first month. So the $100 that we're putting away a month is made at the end of every month. Okay, if that's the case, we don't really have to do anything to adjust our calculator. But on the other hand, if the payment is made at the beginning of the month, we have to make an adjustment to our calculator. So you hit the blue button here, and then up here underneath the 7, see where it says BEG, begin. Click that button, and notice that your display has this begin. Then it's going to calculate based on payments being made at the beginning of each period. So example of this might be rent, for example. You pay rent at the beginning of the month for the coming month. Okay, so that's when you use the begin. On the other hand, if the payment is due at the end of the month, like some auto loans are, then you use end. So what you do is then you hit the blue button, and see then under the number 8 you have in blue end. Hit that. Notice there is nothing on the display. It doesn't say end. Okay, that's the default. Okay, if it doesn't say anything, then you assume that means at the end. Okay, so again, kind of like fool around with that. Go back and forth from the annuity at the beginning of a period, switch back to annuity at the end of the period. Just toggle back and forth to make sure you got that. Okay. Okay, that's the use of the 5 main buttons. You will need this information to do present value calculations. Specifically for capital budgeting, it would be net present value, internal rate of return. I'm not going to go through those in this particular video since I already talked about that in the lecture for the capital budgeting section. Okay, so that's primarily the use of the HP12C financial calculator. This thing is a really powerful calculator, and as you can see, there's all kinds of other functions that you can do, calculations that you can make using this calculator. And again, there's a shortcut methods for doing net present value and internal rate of return and the price of bonds, for example, but that's a little bit beyond the scope of this course, so we won't go through that in this video. Okay, I think that's all. Teresa, did you have any questions at all?
Can I ask a question about something else?
Why don't you wait until after I stop this?
Okay.
Okay. Okay, so any questions specifically about the HP12C?
No.
Okay, okay. So that's it for the recording. I'll stop the recording. This recording, well, I guess if you're listening to it, you've accessed it. But okay, anyway, that's how to use an HP12C calculator. I'll end the meeting. And then Teresa, I'm going to log off and then log back in. So log back in again in maybe 5 minutes.
Okay, thanks.
Okay, that's it for this one. That's it. See you guys next time.